Hey, what's up, guys? Chung here again. And so today, let's take a look at a different type of problem. And number 723, Candy Crush. It's a very interesting problem. I like it, even though it's only a medium problem. But since it's my first time uh, solving this problem, I'd like to share with you guys. So, I mean, I believe many of you have must have played either Candy Crush or at least the Tetris, right? And basically you're given like a 2D degree here, the 2D integer, 2D board here. And mm, basically what's this doing here is that if you have three or more cells or even or candies on this 2D board are the same, are adjacent vertically or horizontally, you need to crush them all at the same time. So what it means that let's say we have a board here, okay? And let's say if we have three to, you know what? Actually, since we have a better answer here. Okay, here. So basically, you have a 2D board here. You're given like an initial state of a 2D board. On the 2D board here, there are some like cells that are the same, adjacent cells are the same. And every time when you see when you see more than three adjacent cells, either vertically or horizontally, have the same values, you need to crush them all. And after crushing those cells, you need to fill those things. So whatever left above them needs to be moved down. Basically, so here we need to crush this four ones here, and after crushing four ones, all everything left will be basically we're gonna move in this 415, this 411, 311, 211, 5 down to fill those those like empty cells. And whatever we filled basically, and there won't be any new numbers coming from the top. As you can see here, after filling these four empty cells, basically there will be some empty cells on the top. Okay, and we keep doing it because after we changing a state, now we have another five here. Okay, and then three here, and we keep doing it until there's nothing to be crushed. Okay, so basically that's the description of this problem. And by looking at this description, I think the first thing to come to the mind is that uh, it's like a recursive solution, right? Basically, we have to keep calling the Candy Crush itself until there's nothing to be crushed. And every time when we call the Candy Crush method, we're gonna scan the whole 2D board, right? From the first one to the last one. We need to check basically every time when we have like a node here, we're gonna scan to the right side, scan the current one, and we also scan the next one on the right, and then the next two ones on the right as well, so that we can keep marking all the cells, right? Because let's say we have a five here. In this case, we have five, 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 five. Let's say we have five fives, adjacent fives, basically. And every time, let's say first time at the beginning, we'll see this five here, and every time when we have a position here, we always look to the right, two cell, the next two cells on the right side. We check if those threes are the same. If they are the same, we'll mark those three cells. Okay, and then if we now we're at this five here. Okay, now we're at this five. Okay, then we still do the same thing. We look at the next two. We also look at check the next two cells. We check if those three are the same. Okay, they're the same again, and then we mark them again until we don't see anything because I so and when we add this five here, okay, we'll mark 555. So right, and then we are at this 5, we see okay, it's nothing, we don't do anything. This 5, there's nothing on the right, are the same. Okay, and so that's the first step. And the second one is that when we mark these values, what value we should use. I mean, at the beginning, maybe someone might come up with, okay, I'll every time when I see those uh, 3 consecutive numbers, I'll mark them to -1. Okay, I'll mark them to -1. Will that work? Probably not. Why is that? Because and yeah, we can take this one as an example, right? Let's say if we have 5, 5, 5, right? And let's say, okay, the first time we see 5, or I saw 3 5s here. If I mark this one to -1, -1, and the -1, okay? And when we see the second 5 here, okay, and then but at this moment, the 5 is -1, okay? And this 5 is also -1. So basically, there's no way we can mark these 2 5s to -1. Basically, we're losing the context here. That's one of the example, and the other one is like this. Let's say we have a 2 2 2 here. Basically, this example. Okay, if we see the vertical twos, right, the 3 twos, if we mark those two to -1, -1, and -1, okay, and when we try to mark the horizontal 3 twos, there's no way we don't know, right? Since this one it has already been marked to -1, we cannot tell what was the original value for this, so that we cannot mark this two to -1. Okay, so for that reasons, instead of using the -1, the fixed values, what we should do is we should always mark this value to the negative version of it. Okay, and every time when we do the checkings, we always we always check with the ABS. We always use the absolute value. Okay, so that's the second. And the last step is after marking all the cells needs to be crushed. How can we do the crush? Okay, so the way we're doing the crush is we scan this 2D board, I mean column by column. Why is that? Because for the crush, those basically each of the columns, the remaining parts, right, will be moved down, right? So from top down, that's why will be scanning the this like the board column by column, and on each columns we always start from the bottom row here, and we're gonna have like an anchor here. Probably we're gonna have like anchor. We're gonna have an anchor I here, and at the beginning, this anchor I will equals to the 9 here, right? Okay, anchor I equals 9, and I'm gonna have another I here. Basically, this I will be starting from 9 here, and every time, basically, I'm looping through this I here, and I'll be using this anchor I to assign the value. I think some of you may already figure out how this thing works, right? Basically, every time, let's say, for example, we are trying to crush this column, this 3 2 here, and every time when we see the number here, we check if the DP, sorry, what DP, if the board IJ is greater than 0. Okay, if it is greater than 0, what do? We simply do a board anchor I, right? Anchor I and J equals to board I and J, right? And in the end, we simply do anchor I. Uh, I'm gonna use that. I'm gonna use a short abbreviation, anchor I -1. See, so this is how it works, right? Basically, if everything is a positive numbers, and we are assigning everything to its original place. Okay, but whenever we see a negative number, which means the number or the cell needs to be crushed, then we simply skip this. In that case, the I will keep going until, in this case, until it sees another number, another positive number. In this case, it's 5 here. Okay, so now the I is 5. Now the I equals to 5. How about the anchor I? The anchor I is still 8, right? Because anchor I is here and I is 5. Now, when we do the assign here, basically the B, this position, right? The ith row here will be assigned to 1. Okay, and then we keep going. Basically, it's kind of like a sliding window or like two pointer, and then we keep this anchor I to assign the remaining part to here, right? And then okay, so that's that. And in the end, right? So we also after assigning that one, we also need to mark this part, the remaining part, to 0. So that's pretty easy, right? We simply mark the board, uh, the board, uh, uh, the let's see how many zeros we have. Yeah, basically, by the time we finish assigning all the all the values for this column here, the anchor I will become like 2, right? So the anchor I will be here. Okay, so since we have this anchor I here, and all it left is we just need to assign from 0 or from 0 to anchor I. We assign from 0 to anchor I to equals to 0, right? So basically that's what how many zeros we need to put on the top. Yeah. Okay, cool. I think that's pretty much everything we need to know before coding, before finishing this solution here. And yeah, and we just keep doing this for each row, for each column. Okay, and then after we have scanning all the columns, we are done with one of the the, the loop, one of the crash, and then we just pass this board to the next recursive call until there's nothing to be crashed. Cool. Okay, with that being said, let's try to code these things up. So, like I said, we need the rows and columns. So I'm going to use the m and n board n equals to the length of board 0, right? So that's that. And we're gonna, yeah, since we need a flag, right, to tell us if there's anything needs to be crashed or not. If there's nothing, then we just simply don't do anything. We can simply return the board. Basically that's our exit condition. And mm, need crash. Okay, how about this? At the beginning it's false. Okay, and so okay, so we'll be scanning the basically we're gonna scan the rows first, and then we're gonna scan all the columns again. So to scan the rows here, I in range and m minus 2. Okay, why is that? Because we will be always checking the next 2 rows. Sorry, we're gonna always check the next 2 cells horizontally. That's why we have to leave a buffer. Otherwise, the I plus 2 will be out of boundary. So for j, and j is the same. It's for all the columns. Basically, like I said, we're gonna use the absolute values to check that. Basically, absolute value of the board and I, j, okay, equals to absolute. I'm gonna copy these things here. I plus 1, okay, and same I plus 2. If they're the same and they're not equal to 0, okay, so that's the short version of few if statement check. Okay, basically if the next three cells are the same and they are not 0, because for the zeros we don't do anything. Okay, right? And then what do? We mark them into the negative version of it. Okay, plus 1, right? I plus 2 to the negative ABS of that. Okay, because at this moment, this one may have already been marked to its negative version. So in order to mark the other two cells here, we have to use absolutely value and then do a minus here. Basically, we're just making sure we're using a negative version of this value here, and we simply do a mark this one to true. Right? Basically, every time we have that, we mark this one to true, and same for the for the candies, I mean vertically. So for that, I will be the same. So for each of the rows. Oh, I'm sorry. Okay, I think I got confused. So here, I mean the rows should be from 0 to n minus 1, but the column is n minus 2. Yeah, because we're checking. Yeah, sorry. Yeah, I mean the okay. So I'm because I was thinking about the to check the three values horizontally, but instead I think I'm doing this vertically first, but I'm going to change it back to you know what, actually, you know what, I'm gonna keep this one since as you guys can see, this one I'm checking the vertical ones, the vertical consecutive like numbers, consecutive like cells. So I'm gonna check the horizontal adjacent cells here, minus 2. Okay, so in this case it's gonna be j plus 1 I j plus 2. Same thing here, right? So j plus 1 I j plus 2. Okay? Yeah. So after that, we just need to do a crash. Okay? After marking everything, we do a crash. I mean, we can check do a need to crash, or it doesn't really matter. Okay? So like I said, we're gonna do the crash column by column. So I'm going to use j here, right? So because I'm using the j to represent the column here in range n here, okay? And then like I said, we have anchor I here, right? At the beginning, it's equals to m minus 1. And we're going to do a for loop here for I in range n minus 1, minus 1, minus 1, okay? And if the board ij is greater than 0, to a board anchor I j equals to the board I and j. Okay, right? So we only assign is when the current cell is greater, is a positive number, and then we just decrease the anchor by 1. And then here, once we have that, and now all we need to do is we have another I here in range anchor. Okay, range anchor, and then we do what? We do a board, right? Board anchor I. Sorry, board I j to 0. Okay, so that's what when we set what's left on the top to 0. Okay, so after that we simply return what? We return the self. We either keep doing it until Candy Crush, right, abort itself. If need crash, right? Else what? Else just abort itself. That's when we stop doing the crushing. Okay. So yeah, I think pretty much that's it. And here we'll check horizontally. Okay. Here check vertically. Here we crush, right? Yeah, let's try to run it. Oops. Let's see. Hmm. ABS. J minus 1. Okay, so let's see. Is there anything wrong? Let me see. Um, I think I know where. What did I do wrong here? Seems like based on this, the so 0, 0. Yeah, I think I here we should do a anchor plus 1. Yeah, yeah, because this anchor here. So let's say for example this 2 here, right? So this column. So the anchor will be by the time. So this is the anchor was 9 here. So when we see the 4 here, anchor will become to 8 and 8, 7, right? 7, 6, 5. Sorry, 8, 7, 6, 5, 4, 3, and 2. So by the time we finish scanning this column, the anchor I will become to 2, right? So for 2 means we have to we need like basically we need to set 3 zeros on the top. So which means since in the Python 2 is inclusive in the range. That's why we need to do anchor I plus 1 to finish our setting here. Okay, and yeah, I think okay. So the test case works. Let's try to submit it. Yeah, it passed. All right, cool. So I mean, yeah, that's it for this problem. It's not a very difficult problem, but it's a like a implementation heavy problem. Basically, you have to implement a few things here. So first, you have to be able to come up with a way to mark those cells needs to be crushed both horizontally and vertically. And then you have to be able to know like you need to do the crush, I mean column by column, and you need to have like 2 pointers here. So the first one is to loop through if the current cell is greater than what or if the current cell is the cell that needs to be crushed, right? If the current one is the one that needs to be crushed, we keep going until we see a cell that's not is does not need to be crushed, and then we're gonna use this anchor I to assign the value, and in the end we simply set the remaining on the top to 0, and we keep doing it until there's nothing to be crushed. Mm. Cool, I think that's it for this problem. Yeah, thank you so much for watching the video. Stay tuned, guys. I'll be seeing you guys soon. Bye bye.